Welcome everybody. This is 4.1. This unit is about rational functions. So let's go over here really quick and talk about what a rational function is. So a rational function, the word is kind of built into the name, ratio. So a rational function is a ratio of two polynomials. Okay, so if we come back to here, we are filling in, this was our starter, we filled in our table. How we came up with that is we took that x value and we just substituted that in, and that ended up giving us our y value, our output, okay? And we plotted that. So we did that multiple times, and so we could get this kind of idea of what's happening in this graph. What do these functions look like? Okay, so as you notice, when we first plugged in -8, we ended up getting a really small number, a -1/8, which was about right here, and we plotted that. And so as you go to as far away you get from that graph, like here I added an extra point. If you plugged in -1000, it would get closer and closer to 0. Okay, for this one it would give you -0.001, which is really close. Its y value would be almost 0. Okay, and if you made that bigger, if we did, instead of 1,000, we did 1,000,000, then it would get even closer to 0. Okay, and then as you get closer to 0, so as we look here at -1, it gave us -1. If we plugged in a half, we ended up getting -2. If we did a fourth, we get a -4, should be right here. If we did -1/6, we would get -6, okay? So as you notice, as we get closer and closer to 0, these y values shoot down or shoot really high on the right side. Why? Because when you are dividing something, 1 divided by something really small is going to give you something that's really big. So like 1 divided by 0.001 would end up giving us 1,000. So it's so close, the x value is super close to that y-axis, but its y value goes super high. Okay, so let's see if we can answer some of these questions really quick. So when x equals 0, describe what's happening in the function. So we haven't really talked about that yet, but if we take that 0 and put that into the function, what happens if we divide something by 0? All right, and you could try that on your calculator. I'd encourage you to do that and see what happens. So it should end up giving you an error. Okay, why? Because you can't divide by 0. Like 1 can go into 1, or 2 could go into 1, but 0 can't go into, or you can't divide by 0, okay? And that will give you an error. So that's why as we get closer and closer to 0, that y-axis, it gets higher and higher, but it will never, ever cross that y-axis. Okay. All right. So will x equal 0, or when x equals 0, describe what's happening? Okay. It's undefined, but as it gets close to 0, it shoots up really high or really low. Okay. Will the y value ever reach 0? So we kind of talked about that. As we get really far on one side, like if we plugged in 1,000,000, we would get 1/1,000,000, but it would not ever get to 0. Okay, so we'd say no, and that's kind of our reasoning why. All right, so here is a really important word here. We're going to be talking about something called an asymptote. Okay, an asymptote is an invisible boundary line that the function approaches. It gets closer and closer, but it never touches at the ends. Looking forward, sometimes you're able to cross the horizontal asymptote, but we can never cross the vertical asymptote, okay? So where do you see those asymptotes in the graph? So I already have those sketched here, those dotted like or dashed red lines, okay? So those are the asymptotes. We have a vertical asymptote and we have a horizontal asymptote. So in this example, the line never crosses those asymptotes. They get closer and closer to them, but they never get to them, okay? So the equation for these asymptotes, again, a vertical asymptote, vertical meaning up and down, right? Vertical asymptotes, if you're writing down a vertical line, it's x equals whatever that number is. For this one, it's going to be x equals 0. Okay, if we kind of look at this, on this asymptote, this vertical line, all of their x values are 0. It doesn't matter what the y values are. If we did 5, x is still 0. If we did 10, x is still 0. If we did negative 7 or 6, x would still be 0. So it doesn't matter what y is. All we care about is x is always 0. Okay? And similarly with the horizontal asymptote, horizontal again is left to right. It's a horizontal line, so we would need to write it as y equals 0. Okay? You're more familiar with like y equals mx plus b, but the slope is 0. So it's just its y-intercept, which is 0, okay, for this example. All right, hopefully that's helpful. And then our last question is, what is the excluded value of x? So what is the value that would break this equation? What gives you an error when you type it in? Okay, and that would be x equals 0. So this is a lot of zeros. We'll come up and do some examples where it's not just always 0, and hopefully this will make more sense, okay? So some of the things we're going to be asked to find for our homework is there's going to be 5. We're going to break it into 2 parts. So start with excluded values. So excluded values, sometimes they're also known as values of discontinuity, so keep that in mind. That's probably what it will say on your homework. Okay, these are the values that make the denominator 0. So dividing by 0 is undefined, right? So that's why we call it discontinuity. So it's a break in the graph, okay? Domain is everything but those excluded values. So domain is all the possible inputs or x values over which the function is defined. So if you can plug in an x and it doesn't cause errors or issues, then it's part of your domain, okay? And then vertical asymptotes, we already kind of talked about that. It's just that invisible vertical line that's caused by the values of discontinuity, okay? So here we've got a few examples. I have these already graphed for you just so you can visualize what's happening. But on your homework, you won't be given the graph. We'll get into the graphs later on, okay? So we're asked to first find the vertical asymptotes. So it's easy to see here, right? It's just this vertical line. We can see them in all of these graphs, okay? We do dotted lines because they're like invisible. They're not actually part of the graph. They just guide the graph, okay? But better off, we probably want to see how do we do it from an equation. So if we look at this equation, we want to know what makes the bottom 0. So here it would have to be x equals 4 would make the denominator 0. So that's our vertical asymptote, x equals 4. If we look at b, what makes this 0? Well, x would have to be negative 5, okay? And then for c, we have 2 factors in the denominator, so we're going to end up having 2 vertical asymptotes. So we'd have either x would be negative 3, that would make this factor 0, or x would have to be 1. So we'd have these 2 vertical lines. Okay, on your homework, it's probably, at least some of them are going to ask you to write it just as a list, like negative 3, 1. It'll already have this part written as your instructions, and you just write this part. But really, I don't really like that a whole lot because these are actually lines, and we need to write them as equations, not lists of numbers. Okay, so just keep that in mind when we get to like the test. Okay, all right, excluded values. Again, excluded values are the things that make the denominator 0. Maybe I should have done that first. So again, what we already kind of talked about that. So x can't be 4. For b, x can't be -5. And the excluded values for c, x cannot be equal to -3 or 1. Okay? And those are actually, you should probably write them as a list of things that can't work, excluded values. Okay? Last thing is the domain. So domain in the past, when we did like parabolas, it was always -infinity to infinity, and that was our domain. But now we're breaking that domain into parts because we have values that don't work. Those excluded values, those don't work for the equation. So we would go from -infinity to 4, and then we'd use a parenthesis because we don't include 4. And then we use a union, that's like u, and we would continue everything after 4. Okay, so again, brackets is where we include, but we won't be using those because those values of discontinuity aren't included. All right, when you're typing this into your homework, one thing that's kind of useful is that infinity, you can just enter, I guess maybe I should do it this side. We could just do 00. If you type 00, it'll do infinity. It just saves you a little bit of time rather than trying to look for it. And then the union, which is like this shape like that, you can just use like a U. It doesn't need to be capitalized. So those are just some little hints when you're typing in your answers. All right, domain for B, we would have -infinity to -5, and then, U, and then -5 to infinity. Okay, and then domain here. So this one you have to start looking a little more carefully. When we write the domain, it has to go from lowest to highest. So you would not want to go -infinity to 1 because there should be a gap at -3. Does that kind of make sense? So we'd need to do -3 first, and then from -3 to 1, and then 1 to infinity. Okay, so smallest to largest, or lowest to highest. Okay. All right, so what's the difference between an excluded value and a vertical asymptote? So the main thing that you need to make sure the takeaway is that an excluded value is a number. It's just a number that makes the equation not work. It's undefined. But a vertical asymptote, we use the excluded values to tell us what the vertical asymptote is, but the vertical asymptote is a vertical line. So it's always x equals. Okay, you could graph it. It's always something like this. Okay. All right, last thing we need to talk about is the x and y intercept. So we've done these before. If you're trying to find your x-intercept, then we can just set y equal to 0 and solve for x. If we need to find the y-intercepts, then we set x equal to 0 and we solve for y, right? So we know that the x-intercept is something, comma 0, and for the y-intercept, we know it's 0, comma something. So we should just be able to use those zeros to help us solve for the missing term, okay? So let's look at this really quick. Let's do the asymptotes really quick. So asymptotes, again, the asymptotes are based off of the denominator. Okay, so what makes the bottom 0? So again, if you wanted to, we could just set this equal to 0 and we could solve for x. So we get x equals -1. So that's our vertical asymptote. For this one, for B, x is by itself, so it's just, we set it equal to 0, and look, we're already done. So we could write that down. So x equals 0. Okay. If we're trying to find the x-intercept, what we want to find is what makes the top 0. So typically what we did in the past is if we had something like this, then we break that into the two parts and would say, well, either x has to be 0 or x minus 5 has got to be 0, and we would solve. So we'd have to add 5, and you'd get x equals negative 5, or positive 5. Okay, so then our x-intercepts are ordered pairs. So we would have 5, 0, and then for this one, it's just 0, 0. So let's try the other one. So what would make the top be 0? Well, x would have to be negative 2. So our x-intercept would be negative 2, 0. Okay? All right, then the last thing is we want to find the y-intercept. So the y-intercept, again, is where we set y equal to 0, and we solve. Okay? So I think sometimes it's easier just to look at this and say, well, what part of this ratio could go make the equation 0? Okay? So really, oh, sorry, that's what I just probably talked about. Sorry, y-intercept is where we just set x equal to 0. So let's just do it over here. I think I got mixed up there. Sorry. So we'd plug in x for 0. And you could use a calculator. If you use a TI, something that's really helpful is if you just type alpha and then y equals, and then you give the first choices, you could make it look like a fraction. So sometimes that's helpful if you want to give that a try. But anyways, you could do this, would get the top part would just give us a 0, and the bottom would be 1. So our y value is 0. So we'd write it as 0, 0, which makes sense because our x-intercept is also 0, 0. Okay, let's try another one. So again, if we're trying to find the y-intercept, we set x equal to 0, and we'd end up getting 2 over 0. And again, we said we can't divide by 0, so this is undefined, and we would write D and E, does not exist. Okay, that's what it will ask you on your homework. All right, last one. We won't be focusing a lot on the factoring part until next time, but just to get you a head start, if you have something that's not factored, we would want to factor it. So this is the difference of squares, so we would just have x minus 3 and x plus 3, or you could think of it as what multiplies to negative 9 and adds to 0, and you'd get the same thing, right? So you need to make sure you factor before you start to find like the x-intercepts or the vertical asymptotes. So vertical asymptote, what makes the bottom 0? Well, x would have to be negative 2. If we're trying to find the x-intercept, again, we're trying to find what makes the numerator 0. So either x would have to be 3 or negative 3. So we'd write down our x-intercepts would be 3, 0 and negative 3, 0. And then the y-intercept, again, we just set x for 0. So I'm going to actually use this form. I think it's a little easier in standard form. So we get 0 squared minus 9 over 0 plus 2. So that's just gone. And we just get negative 9 halves. So we'll have 0, negative 9 halves. All right, so that's pretty much it. I have a few extra examples. If you feel like it's helpful, or if you find one on your homework that looks similar, you could always go and listen to the rest of this. I will go through that a little quicker. So again, if we're trying to find the y-intercepts, this would be x equals 2. I'm just going to go and do all the others. So here, x would have to be 0, or x would have to be negative 2. And if we're trying to find the vertical asymptotes, we would need to factor this, the denominator. So we have x minus 2, for the top and for the bottom, what multiplies to -5 and adds to -4? I think that would be, maybe I'll write this over here. So multiplies to -5 and adds to -4 should be -5 and 1. So it would have x minus 5 and x minus, or plus 1. So now we can write down our values of discontinuity, or vertical asymptotes. So either x would have to be 5 or x would have to be -1. Okay, so we could write those all down. Again, the values of discontinuity are the same, it's a value, so x can't be 2. Here x cannot be 0 or -2, and here x cannot be 5 or -1. The domain, again, -infinity to 2, and then 2 to infinity. Domain here would go -infinity to, not 0, -2, and then -2 to 0, and then 0 to infinity. And then this one would go from -infinity to -1, -1 to 5, and then 5 to infinity. Okay, vertical asymptotes, we already wrote that up at the top, so I'll just write those here. X-intercepts, again, we want to find what makes the top 0. So this 3 out here, that doesn't really affect what we are trying to find. So we would just have either x is 0 or x equals 4. For the next one, would say, again, that negative, it tells us about like reflection over the x-axis. It will help us with our horizontal asymptote, but won't affect our zeros. So here x would either be -4 or x would have to be -3. And then here we'd have x equals 2. So we could write those x-intercepts 0, 0, and 4, 0. This one would be -4, 0, and -3, 0. Here would have 2, 0. And then the y-intercepts, again, it's just plug in x for 0. So we'd get 3 times 0 times 0 minus 4 over 0 minus 2, and would end up getting 0, which makes sense because the x-intercept is also 0, 0. For this one, we would get what? -0 plus 4, 0 plus 3, 0 times 0 plus 2. So here we would end up getting -12 over 0. So that is D and E does not exist. And then for our last one, we'd get 0 minus 2 over 0 minus 5 times 0 plus 1. And that should give us -2 over -5, or 2/5. So 0, 2/5. Okay. Sorry, I kind of went through that part really quickly. But if you have any questions, please let me know. I'd be happy to help you. Okay, we'll see you guys.